Hi everyone, my name is Roman and I'm presenting you our paper for the fourth Ukrainian Natural Language Processing workshop this year on the ACL. Um, our paper named Vuyko Mistral, Adapting LLMs for the Low Resource Dialectal Translation. So the goal of our study is to adapt low resource language and especially its dialect for usage in LLM. Uh, we were concentrated on the one of the dialects of Ukrainian language, which is considered a low resource language, and this dialect is called Hutzul, as you can see this on the map. It's where this red one. So basically, it is from the dialect of Ukrainian. It's maybe the most well documented. That's why we stopped on it. And actually, basic idea was to create the corpus of it, to preserve it, and to make actual experiment of how LLM can handle it because it's quite different from the original Ukrainian language, as you will see a little bit later. So Hutzul dialect is actually the dialect that is spoken in the mountains. Here it is. It is the Carpathian Mountains, and it's spoken there. And the main written part of this dialect is the book called Dialectal. Here it is. As you can see, it's quite large, but it's here it is as twice large because it is translated to Ukrainian in standard Ukrainian in the same book. But anyway, we had quite a lot of pairs there. So actually, we had nearly 10,000 Utsul standard Ukrainian parallel corpus taken from this book. Also, we took another um, another as another source, different different magazines, different well, all the texts that we could find. And actually, the dialect itself is quite different from Standard Ukrainian, as I said earlier. So what, as you can see, it's like changing the actual phonetics, changing the morphology, and basically it is heavily influenced by most German and Polish lexicons. And actually, it's quite difficult sometimes to even to understand it ourselves. And standard LLMs are not handling it very well because uh, the majority of training data is English, and Ukrainian is not even 1% of the training corpus is used for big LLMs like GPT. And so it's not handling it that good, and we decided to give it a try and to make it adapt for the translation task. So what we did, we created a corpus. For the corpus, what except of the book and except of the sources that we have found, we have created a synthetic data. So this synthetic data was created not only like through the GPT itself, but it was also created using the RAG augmentation. And what we did, we actually took the our actual dialect sources, put it through GPT-4o, and we got the rules out of it. We compared it with the rules in the literature that we could find and created the decent amount of rules the model need to follow. The next thing what we did is we took the corpus named Ubertext, made by Lang UK, and we tried to translate it using this our rules and GPT-4o to actual Hutzul. Um, the results were not very good. So what we added the reg to it. We actually created a reg out of our sources, the original Hutzul sources. And what we did next was that we took this. the sentence from this Ubertext corpus, and we added the RAG as an examples to it. After it, we trained the small LLMs. So we stopped on the Llama, on the Mistral, and basically calculated the metrics that we decided were good. So yeah, as you can see, here is our pipeline. So we did, as I have already said, we did a rag from our source. We took another corpus and we created the synthetic data. Basically, as you can see, we targeted the U source, which is the uh, number of symbols that were in source, and the U target, and X is where we calculate the transaction between symbols in dialect and standard variants of the sentence. And as you can see, we have quite lower X here, which is quite a problem because in this dialect, some words are changing places in the and it still remains a problem. So we've got the results that we were looking for that were quite okay. But considering that we didn't have the people who are freely speaking this dialect, we decided that for this part it will be okay. So having increased this our corpus, we created we started to train our models. The one thing that I also want to mention here is that despite of creating this synthetic data, we were limited by the vocabulary. So we tried to use only some kind of sentences that were similar in topic to original texts that we had, because these texts they don't have the modern words. So if you try to describe some kind of politics or news with it, it will just give you the normal Ukrainian words, not not dialectal. So basically, the training was simple LoRa with three epochs, and as you can see, we decided to calculate the blue score, the CHRF plus score, the translation error rate score, and actually, this is fluency, adequacy, and dialect are scores that we created using the GPT-4o as a judge to it. Um, so basically, as you can see, um, we had the Mistral with synthetic data and manual aligned text having the best score overall. And it is the model that we present. You can find it as well as a corpus on the Hagen phase. But at the same time, we acknowledge that it is far from perfect, and we are looking forward for creating the bigger corpus with more topics. And for that, we are planning to enrich our corpus with new data. We are planning to gather the data from the people who are actually speaking this, and yeah, after that, we hope to improve the model even further. So thank you for your attention.